right, good afternoon. So we are writing quadratic equations in standard form today, okay? Two things that you're going to need to know are our learning objective. Of course, we will write quadratic equations in standard form. If you're taking notes, which I strongly recommend, I would write that on the top. The two things, vertex form and standard form. So if we're going to write something in standard form, we have to know what it is. That's simply y equals ax squared plus bx plus c. Okay, should look familiar to you. Now the vertex form we've talked about more recently. Of course, that is y is equal to a, but it includes the parentheses, x minus h. H is for your horizontal movement, and then plus k. That tells you your movement up and down, right? And of course, A, that controls vertical stretch and vertical compression along with reflecting over the x-axis. Good. Let's go ahead and let's look at our first example. So we're going to start off with the vertex form. Y is equal to, again, A times x minus h to the power of 2 plus k. H being your horizontal movement and K being your vertical movement, that you get from your vertex. Remember that your parent quadratic started at the origin. So this tells us, hey, we moved down by 4. That's K. That's right there. It also tells us that we moved to the left by 3. That is H. Okay? Then for X and Y, because we're going to plug in what we know and solve for what we don't. For X and Y, simply pick any other point that lies on the parabola. I'm going to choose this one because I think it's easier. So let's try it. I'm going to go ahead and I'm going to write down X and Y. Okay, so let's plug in everything. Y, of course, is 0. A, I don't know what A is. X is -1. Now keep in mind, we have a minus that was already there, right? And so then I'm going to put in H. H happens to be -3. So yes, you would want two of them, right? One was already there, and H is actually -3. And then we have the plus. That also is already there. And then we have K, which is finally -4. See where we're getting our H and our K from? Let's go ahead and clean it up a little bit and solve for A. I got a lot of negatives there. So -1, negative times a negative, +3. Positive times a negative, negative. Okay, 3 minus 1, 2. 2 squared, 4. Okay. And I'm going to go ahead and solve for A by adding the 4 to both sides. So once it's completely simplified, as far as I can take it, I'm going to go ahead and get A all by itself. So we add 4 to both sides. So of course, we'll zero out. And I'm left with 4 equals 4 times A, right? Divide by 4. So now that A is completely by itself, we know that A is actually just equal to 1. Okay, great. When you write an equation, what are the only two variables that you leave? Good, X and Y. So let's go ahead and plug in everything other than X and Y. We got Y is equal to something times X minus something else squared and then plus something. So let's go ahead and plug in what we now know. So I know that A is 1. I know that H is -3. And I know that K is -4. Okay. Let's clean it up just a little bit. We don't want any double negatives or unnecessary ninjas. So essentially, this is just an unnecessary ninja right there. We end up with a negative times a negative. Notice how when it was opposite, it's positive 3, so we know, oh, we moved to the left. See? Positive times a negative, negative 4. So this would be the vertex form right here. Only problem is that we want to actually write it as a quadratic. So this is where we continue to break it down and simplify even further. We're going to go ahead and use a little box. You can use foil. Sometimes you can even just know it because you've done it so often. This is x plus 3 times x plus 3. So in this box, we got x times x, which is x squared. In this box, we got 3 times x, which is 3x. And in this box, 3 times x, 3x. And 3 times 3, which is 9. Okay, let's go ahead and combine our like terms. And so we end up with y is equal to x squared. 3x plus 3x is 6x plus 9 minus 4. Don't forget to bring down that minus 4 because it wasn't part of all of that, right? Combine your like terms. 9 minus 4 is positive 5. And what you can do, just to kind of double check, I encourage you can go to Desmos and just click on the big red button and you can kind of see, let me go in here, y equals x squared. Okay. Y equals x squared plus 6x plus 5. And so we can kind of compare what we were doing here. We got negative 3, 4, and solutions at negative 5 and negative 1. Let's look over here. Click on there. Oh, there's negative 3, 4. There's negative 5. And there's negative 1. So we were able to correctly write the correct equation for this. Okay? So our final answer is, go and just highlight that. Okay, in standard form, this is our equation for this particular parabola. Parabola? Let me think. Parabola is the shape. And yeah, so there we go. Let's go ahead and let's look at the next thing here. Okay. Now we're looking at this quadratic right here. We're going to have to identify these specific points, the vertex right here, and we can pick any good point. Remember, a good point is where you have 3 lines, right? A vertical line, a horizontal line, and that it actually lands on the parabola. I'm thinking this one, just because it looks like a good one. Sometimes the y-intercept's a good point, just doesn't really matter. And let's go ahead here. I'm going to go ahead. This is negative 3. Ooh. Negative 3, 0. Wait. Oh, that's so wrong. It's negative 3, negative 2. My bad. Okay. Negative 3, negative 2. And then this point right here, that's negative 2, 0. Make sure I got my points right. Yes. Okay, good. So this is x. This is not x. This is x. Boy, don't do this after lunch. Let's see. This is, do you remember what that one is? It's h. Good. So h and k, and this one is x and y. Okay, we're going to start off with our equation. Y is equal to a times x minus h squared plus k. Okay, let's go ahead and plug in everything except for what we don't know, which is quite a bit. Let's see, we got that. So I think we can plug in everything. And so y was 0. Again, there's the y, the 0, right? We got x. X is negative 2. H, negative 3. Okay. Plus the k, which is negative 2. Let's go ahead and clean this up a little bit. Let me double check that I did everything okay. Yeah, I think I did. Okay, so negative times a negative. Positive. Positive times a negative. Negative. 3 minus 2. 1. 1 squared. 1. So that's the same as 1a, right? 1 times a minus 2. So now it's completely simplified. Add 2, add 2. And if you were saying, do we really need that 1 there? No, we don't really need that 1. It's just a, right? And 0 plus 2, of course that zeroes out. And 0 plus 2 is 2. So we've got a is equal to 2. Let's go ahead and let's write it into vertex form where we leave everything except for the x and the y. So y will equal something x minus something squared plus something. Plugging it all in, a is 2. H is negative 3. And k is negative 2. Okay, cleaning it up right here, we're looking at just kind of removing those ninjas and double negatives. Again here, if we were wanting to know what the vertex form is, oh, and I forgot this. This would be vertex form. Of course, we're writing it in standard form, so we take it to the next step. We do our little square. I probably could make that a little bigger, but x plus 3, x plus 3, so x squared, 3x, 3x, I totally could have made it bigger, plus 9, right? Combining those like terms, we end up with y is equal to 2 times x squared. 3x plus 3x is 6x plus 9 minus 2. Okay, now we go ahead and move forward with the distribution. Only the terms inside the parentheses. Remember, we stop at the end parenthesis. So we're looking at y is equal to 2x squared plus 12x plus 18 minus 2. These are like terms. Y is equal to 2x squared plus 12x plus 16. And ladies and gentlemen, this is our final answer for this problem. Okay, let's work through another. So what if we didn't have the graph, right? What if we didn't have the graph? Well, no big deal. We have what we need. You know, we have this right here. That's important. And we can pick one. I'm going to pick this because it's got smaller numbers. So here we go with this one. We're going to label this as x, y. It's just a random point. The vertex is the special point, and that's where we have h and k. Okay. Start off with our vertex form. Y is equal to a times x minus h squared plus k. We're going to plug in everything we know, solve for what we don't. So I know I'm going to know x, y, h, and k, and I'm leaving everything else in. So y is 4, x is 1, h is 2, oh yay, no negatives, and k is 3. Cleaning it up, 1 minus 2 is negative 1 squared plus 3. Okay, what is negative 1 times negative 1? Just 1, right? Okay, we're going to go ahead and subtract 3, and a times 1 is just 1a, or just a. It's kind of a ninja. 4 minus 3 is 1, so we know that a is equal to 1. If we wanted the vertex form, we would just write it as 1 for the a, right? Leaving in the x, minus h. H ended up being 2 squared plus k. K was 3. No double negatives. Okay, we got a bit of a ninja. We can leave it out. And this is our vertex form. Okay. However, what we need is the standard form. So let's go ahead and do our little box. I'll promise I'll do it bigger this time. And we're doing x minus 2, x minus 2. So we're multiplying x times x is x squared. Negative 2 times x is negative 2x. Negative 2x. And positive 4, combining like terms. So here we go with x squared minus 4x plus 4. I'm going to go ahead and replace this with that. I'm going to add the 3, combine like terms, and y is equal to x squared minus 4x plus 7. Okay, and that is, of course, standard form. Last one. What I might encourage you to do is simply pause, try it yourself, see if you get what I get. If you do, great, move on. If you don't, go ahead and listen to the explanation. So this can be, I'm going to pick this just as a random point, x and y. I'm going to choose this as my, a problem with zeros, and it passes through that. Okay, well maybe this was not a good one to do on your own. Let me go ahead and let's just kind of see what this would look like. Let's go to Desmos. I'm going to get rid of that. Now we can always add a table. Okay. And this you could do on graph paper, if you didn't have that. So I'm going to put in the points 1, 0, and 3, 0. 1, 0, 3, 0. And then I'm also going to put in the points negative 2, 3. Okay. So let me go ahead and kind of get in there like this. Let's see what we can figure out with symmetry. So we know that it's probably something where it's kind of got a line going like that, right? We know that the middle is going to be right there. Yes? Okay. So we know that the x-coordinate of the vertex is going to be 2. I'm not sure about the y yet. And do we have enough information? At this point, so I'm looking here and I'm trying to determine, we know that there would be another point right here. So that would be like 6 and 6, 3, I'm thinking. Let's see if that looks right. Yay. And we know that there's going to be a point here. We just don't know exactly whether or not. Okay. So, we can take a guess out of it, and sometimes without the calculator, this is kind of, we can do this, but let's go ahead and I don't know, I'm going to take a whirl. I'm going to say 2 and negative 0.5. And I just hoping that I don't make it, let's see how close we get. Why not? So I'm going to go with 2, negative 5. Let me go ahead and write this down. Okay, 2 and negative 0.5. This is going to be my horizontal movement. This is going to be my k. Okay, so we're going to start off with our vertex form. And plug in everything. We don't know what a is. X is 1 minus 2 squared and plus a negative 0.5. Oh, hope that's not too ugly, but okay. And let's go ahead, clean it up a little bit. 1 minus 2, that's negative 1 squared plus, we didn't really need, let's erase. We're going to make it minus, we could do minus 1/2. Okay, I don't know why I feel more comfortable with fractions. So negative 1 times negative 1 is positive 1. So that's just going to be 1 times a, or a times 1, right? Let's go ahead and add 1/2 to both sides. And we have 1/2 over here. 0 plus 1/2 is just 1/2. That just goes away. And a times 1 is just a. So a is actually 1/2. Okay? Let's go ahead and let's look at putting together our vertex form. Leave the y, put in the a, leave the x, put in the h, and then minus 1/2. Okay? Let's go ahead and this would be great if they wanted vertex form. I'm going to go ahead, x minus 2 times x minus 2, x squared minus 2x minus 2x plus 4. Combine like terms. This leaves us with x squared minus 4x plus 4. So let's see what this looks like. 1/2 times minus 4x plus 4 minus 1/2. Okay, we'll go ahead and distribute. And we're leaving it as 1/2 x squared. What's half of negative 4? Negative 2. Half of 4? Positive 2. And then we stop because we have the end of the parentheses. Minus 1/2. These two are my only like terms. And so I have 1/2 x squared minus 2x. Let's go ahead. That's 1.5. We could do that. Plus 1.5. Or what? 3 over 2 is the other option. We could do that. Why not? Let's be consistent. Okay. So let me go ahead and put this in. So here I went ahead and put it in, and it hit those points pretty good. It hit our vertex that we guessed at, but obviously it wasn't compressed enough, right? It wasn't made wide enough. So what I did is I kind of wrote this next equation here in vertex form. And I kind of lowered a, made it an even smaller number, and it kind of raised up the vertex just a little bit. And as you can kind of see, that would hit just a little bit better. So there are some cool things on the calculator with regression that you'll be able to learn next year, but that last problem would have been a very tough one to do without the calculator, right? Okay. Well, I hope that the first 3 questions were really easy, and the ones that I give you are going to be along those lines, but I just kind of wanted to push you a little bit. Have a great day, and tomorrow we will be doing, I will post a check your understanding, and again, I'm available on Zoom from 2, and I think I'm going to be extending it to 3:30. So if you are somebody who 2 o'clock does not work, you can come see me at 3 as well. Okay? Take care. Bye-bye.